Okay guys, welcome to quadratic word problems where we are doing projectile motion. Alright, so here's the problem that we have. A ball is thrown into the air with an initial upward velocity of 48 feet per second. Its height h in feet after t seconds is given by the equation h equals negative 16t squared plus 48t plus 4. If you're like, wow, where on earth did that equation come from? This is an important equation that we will be using this whole time. It's right here. Some of you might have seen it in science class before. It's h equals negative 16t squared plus vt plus s. H is height. Negative 16, that's always the number you will use in the equation. It's for gravity, and when an object's falling, it takes into account gravity. T is time. V stands for initial velocity. So velocity just means speed. Initial means starting, so starting speed. And S stands for the starting height. So how high up off the ground is the object starting from? And so in this problem, you were given the equation already filled in, but that won't always be the case. So again, it's always a negative 16. 48 goes here because v is your initial velocity. It says it starts out with an initial upward velocity of 48 feet per second. And then you have a plus 4 here because remember the starting height is always your plus s. And it says its height, oh gosh, where was it? Oh, it actually didn't tell you that. Okay. So in the words, this actually means it was thrown from 4 feet. So maybe somebody kicked it from 4 feet off the ground. So again, here's your visual. Actually, they're throwing it. They're not kicking it. And if we were in class, I would do my lovely visual. So someone's throwing this ball, okay? And just as a visual, it's 4 feet off the ground when this ball leaves that person's hand, okay? And when it's starting to be thrown, an upward velocity of 48 feet per second. So all of these, if you were to go outside and throw a ball, even if you threw it straight up, it's going to reach a peak. So if you're on the ground and you throw a ball straight up, it doesn't just come straight down and hit you in the face. It will have a little bit of a turn to it and come back down. So all of these that we are dealing with are quadratics. They're all parabolas for this whole section right now. Okay, and there are 3 types of questions that I will be asking you for these types of problems. The first one is, what is the ball's maximum height? So, back to my lovely drawing, that is the maximum point. That's the vertex of this parabola. And so remember, in this case, what is your x? What's in place of x in this equation? Your time. So this is always t comma h. Why? Because t is in the spot of what x would be, and h is in the spot of what y is. So what is the ball's maximum height? Well, first of all, before we actually figure out that question, we need to say, well, which variable are they actually wanting us to solve for? So the maximum height, we're looking for h of the vertex. But think about it. To find h of the vertex, you need to know the x first. You need to know the time. So that brings me to question B, and sometimes I will ask these out of order to see if you know what you're talking about. How long until the ball reaches its maximum height? So that is your time. That will tell us how long it takes to reach the maximum height. Okay, so I'm actually going to find this first with the equation that I gave you. H equals negative 16t squared plus 48t plus 4. Okay, so how long to reach the maximum height? That is, again, I'll say it again, the t, it's the x of your vertex. So remember, this is in standard form. And in standard form, how do you find your x-coordinate of the vertex? Negative b over 2a. So in this problem, your b is 48. So negative b is negative 48 divided by 2 times your a, which is negative 16. So that's negative 48 divided by negative 32. And you want to make sure you simplify that. That's going to give us 1.5. And yes, you can write it like that. So again, I'm answering question B first because I need that number to actually solve for A. So how long until it gets to that vertex point? 1.5 seconds. And how do I know it's seconds? Because of the time in the problem, is in seconds. Okay, now I can go back up and answer A. What is the ball's maximum height? Well, I know it takes 1.5 seconds to get there, so I'm going to take my equation and put 1.5 in for t. So we've done all this before when we were graphing quadratics, when we were graphing parabolas. Now we're just actually applying that math. So you need your calculator. I'll take it one step at a time. 1.5 squared is 2.25. And then 48 times 1.5 is going to be 72. Okay, so now I'll just do an extra step. Negative 16 times 2.25, that's going to give you negative 36, plus 72 plus 4. So you're going to throw all that into your calculator or in your mind, and you're going to get 40. So what did you just find? 40 feet. And again, I know it's feet because of the unit up here. The maximum height of this ball is 40 feet. Okay, the third type of question that I'm going to ask you is how long until it reaches the ground. So, oh gosh, I gotta redraw my picture here. So you throw a ball, and it's gonna come back down to the ground. So in our situation, remember, this ball was thrown from 4 feet off the ground. That's where it left the person's hand. Okay, probably not a person, I don't know. Anyways, and so we want to know how long until it reaches the ground again. Well, if 4 feet, it left the woman's hand from 4 feet off the ground, what would the height be on the ground? What do you think we're going to think of ground as? Hopefully you're saying 0. Okay, so what I'm doing is I'm rewriting the equation from the front. What the heck was it? 48t plus 4. So it's that equation from before. In A and B, and all I did was put 0 in for h. Why? Because that is the height on the ground. So to solve this, you can either factor or do the quadratic formula. I'm running low on time here on my phone, x or t. So I'm going to do quadratic formula. So negative b. So negative 48 plus or minus the square root of b squared minus 4 times a times c all over 2a. So the denominator will be negative 32. Inside, I'm going to do this all in one step because we've been doing this for a while now. 48 squared minus 4 times negative 16 times 4. That's going to give me 2,560. So let's actually get a number for that. The square root of 2,560, just to have, I know it's a decimal, but I need to figure out what it is. It's 50.6 when I round. So now, this means nothing to me, right? I need to answer the question. So remember, your two answers here are 48 plus 50.6 over negative 32. And your other one is negative 48 minus 50.6 over negative 32. So let's put this first one into your calculator. Negative 48 plus 50.6, hit enter, and then hit divide by negative 32. That's going to give you negative 1.8125. What the heck? Now do the other one. Negative 48 minus 50.6 divided by negative 32. That gives you 3.08. Okay, guys, you didn't make a mistake. So this, I'll actually go up to my drawing. This negative 0.08125, that's if I were to extend this parabola way back here. It doesn't make sense, but that's where it actually would cross the h equals 0 or the x-axis in terms of the parabola. So in terms of the problem, this is not an answer because we're not talking about negative time. This is what I would be looking for you to say, 3.08 seconds. And there you have it.